In this video, we are going to study about DeBroglie wavelength. We know that a wave has dual nature. It has the properties of a wave and the properties of a particle. Because it behaves like a wave, it has a wavelength lambda. Because it behaves like a particle, it has a mass m. DeBroglie gave the relation between lambda and m. Lambda equals h over mv, where h is Planck's constant and v is the velocity. Let us see how the units work out. Units of Planck's constant is joules second, unit of mass is kilograms, times unit of velocity is meters per second. Energy has units joules. Energy is force times distance. Force is mass times acceleration. So, unit of force is kilogram times meters per second square. Units of energy is kilogram meters per second square times meters, because energy is force times distance. So units of energy is kilogram meter squared per second square. Plugging this in, lambda equals h over mv, we get units of h is joules second, so that is kilogram meter squared per second square times second, over mass, which is kilograms times meters per second. This is for h over mv. Again, Planck's constant has units of joules second, which is kilogram meter squared per second times second, over mass, which is kilogram, and velocity, which is meters per second. This gives us units of meters. So lambda will have units of meters or distance. Coming to the first part of the problem, calculate the DeBroglie wavelength of a mass of 1.0 grams traveling at 1 centimeter per second. So lambda equals h over mv, 6.626 times 10 to the negative 34 joules second, over mass is 1 gram. 1.0 grams is 1.0 times 10 to the negative 3 kilogram, because 1000 grams equals 1 kilogram, times velocity is 1.0 centimeters per second, which is 1.0 times 10 to the negative 2 meters per second, because 100 centimeter equals 1 meter. Solving for lambda, we get 6.6 times 10 to the negative 29 meters. Next part. Calculate the DeBroglie wavelength of a mass of 1.0 grams traveling at 100 kilometers per second. So lambda equals h over mv, which is 6.626 times 10 to the negative 34 joules second over mass, which is 1.0 grams, 1.0 times 10 to the negative 3 kilograms, times velocity, which is 100 kilometer per second. 1000 meters equals 1 kilometer. So 100 kilometers is 100 times 10 to the power 3 meters per second. We get lambda equals 6.6 times 10 to the negative 36 meters. The last part, calculate the DeBroglie wavelength of a helium atom traveling at 1000 meters per second. So lambda equals h over mv. The velocity is given as 1000 meters per second, and we know the value of h, so we can plug that in. What about the mass of helium atom? From the periodic table, we can see that molar mass of helium is 4 grams per mole. So mass of a helium atom is 4 grams per mole over Avogadro number, which is 6.02 times 10 to the 23 per mole. Since we want this in kilograms and 1000 grams equals 1 kilogram, mass of helium in kilograms would be 4.00 times 10 to the negative 33 kilograms per mole over 6.02 times 10 to the 23 per mole. Plugging this for lambda, we get 99.8 times 10 to the negative 12 meters. Next problem. To what speed must electron be accelerated to have a wavelength of 3.0 centimeters? This question is from Atkins. Again, we can use the DeBroglie equation, lambda equals h over mv. We need to find the speed, so we can rearrange to write v equals h over m lambda. We know the Planck's constant h. Wavelength is given. Mass of electron is 9.1094 times 10 to the negative 31 kilogram. So we can plug these values to find the speed. V equals 6.626 times 10 to the negative 34 joules second over 9.1094 times 10 to the negative 31 kilogram times 3.0 centimeters times 10 to the negative 2 meters, because 100 centimeter equals 1 meter. That gives us a speed of 2.4 times 10 to the negative 2 meters per second. Let's do one more problem. The fine structure constant alpha plays a special role in the structure of matter. Its approximate value is 1 over 137. What is the DeBroglie wavelength of an electron traveling at alpha.c, where c is the speed of light? This problem is also from Atkins. We can use the DeBroglie equation, lambda equals h over mv. We know h. Mass of the electron is 9.1094 times 10 to the negative 31 kilogram. So speed is given as v equals alpha dot c, where alpha is 1 over 137 and c is the speed of light, which is 2.9979 times 10 to the 8 meters per second. So plugging in these values, 6.626 times 10 to the negative 34 joules second over 9.1094 times 10 to the negative 31 kilograms times 2.9979 times 10 to the 8 meters per second over 137. Calculating this, we get lambda equals 332 times 10 to the negative 12 meters.